Hello everyone, my name is Brian Schmidt and I'm the Vice Chancellor of the Australian National University. But I'm also an astronomer up at Mount Stromlo Observatory. Today I'm joined by Chris Wolf, who is the Principal Investigator of the SkyMapper Telescope. SkyMapper Telescope, shown here, is releasing its survey, or at least we are releasing our survey, of the entire southern sky. And that's a real picture of the telescope that was built after the fires destroyed the telescopes up at Mount Stromlo in 2003.
Yes, and I think next we can see a picture of the sky itself with the southern hemisphere down here, and up there what's black is the northern hemisphere that we do not look at. But this picture of the southern hemisphere does not look impressive to you right now. We have to zoom in order to see something interesting, because there are more than 300 million stars in there that we are investigating.
So it's not a particularly exciting piece of the sky we've zoomed in, but it just shows you how rich the sky is. Every one of these stars is a star like our sun, most of which solar systems not unlike our sun. So within this multitude of stars, there's some really interesting things out there. And in this case, we see something that's not a single star, but rather a collection of stars. And that is the Small Magellanic Cloud, which Chris has conveniently revealed. So the Small Magellanic Cloud is a dwarf galaxy that's orbiting the Milky Way. And actually the Milky Way is slowly consuming it. And our colleague, Naomi McClure-Griffiths, has shown that it's literally being cannibalized. There's 1 billion stars in this galaxy, and you can see it, for example, tonight by looking up, looking to the south from a dark site, and you can see this little smudgy splash of what looks like literally like a cloud, but is literally billions of stars.
In fact, many people mistake it for a cloud and do not know that it's an astronomical object.
Yeah, one of the Magellanic Clouds. Now, near the Small Magellanic Cloud, we have one of the more interesting objects in the sky, which we're going to zoom in on. And this is known as 47 Tucanae. And 47 Tucanae is what we call a globular cluster, a relic of an earlier age. There are roughly a million stars orbiting like a swarm of bees here. And there are literally hundreds of these across the sky, this being one of the most nearest and easily seen. You can actually see this if you know where to look with your eye. It looks like a little cotton ball in the sky, quite
and look,
faint.
Brian, you can see all the individual red giants that live in this cluster if you zoom in close enough. With that red color.
Yeah, that red flash of color tells you these stars are cool, and it turns out very large. They're bright because they're big, and that's the state our sun will take up in roughly 5 billion years or so when it runs out of hydrogen in its center.
This is one of my favorite objects in the southern sky. It is the Eta Carina Nebula. And there is a star in here which 170 years ago was one of the brightest stars in the southern sky. It was almost exploding as a supernova, but it did survive, lost a lot of material. Now, these nebulosities here, they are just gas, hydrogen and oxygen gas, floating in space and being illuminated by the stars. The blue parts are hotter and the green parts not quite as hot. And it seems that in this part here, the nebulosity was missing, but that's not true. All this black here actually means dust clouds that are hiding the green and blue that is actually behind it. So the Milky Way is really three-dimensional.
So Chris, you know, I study supernovae, and I have some hope that Eta Carina will actually supernova for real in the future rather than just belching off its outer bits. But we need to wait and see. Probably in the next 10,000 years or so, if it's going to happen at all.
Hang around.
All right, so one of the things that we are using SkyMapper for is to look for needles in the haystack. So 300 million stars out there, and we have this very precise color information for every single one of them. And that information allows us to pick out very rare objects. For example, stars created right after the Big Bang, before there was any iron in the universe, because the iron gets formed in those supernovae when they explode. So this very innocuous star that Chris is pointing at happens to be the only star known in the entire galaxy that has no measurable iron. The amount of iron in this thing is less than 10 million times the amount in the sun. We can't measure it, even with the biggest telescopes on planet Earth. And it's stars like this that make us understand how the first stars were created back, probably 13.5 billion years ago, just after the Big Bang.
And another needle in the haystack that we use SkyMapper for is black holes, giant black holes in the early universe that we see 13 billion years back in time, shortly after the Big Bang has formed them. So here in this image we actually do not see the black hole, but we know that right at the center near the cross, the biggest black hole in the early universe is located. It's got the mass of 5 billion suns. Now, the way to see it is to use the color information of SkyMapper, and we have to switch channels here to a sort of near-infrared type of light that the human eye cannot see. And once we do that, a little blob of light appears. This is the heat released as this giant black hole swallows up more and more matter and grows further and further. This little blob of light actually is brighter than 1,000 times our whole Milky Way galaxy, if you put it next to it.
And its light's been traveling for almost 12 billion years. So the fact that you can see it at all tells you how bright it must be.
And indeed, if you know about redshift, the reason why we had to go to the near-infrared light is the light from this black hole is so much redshifted that in the color image we cannot pick up anything.
All right, the sky is littered with interesting objects, galaxies like our own Milky Way. Well, here is just one of the multitude of galaxies out there. And another galaxy, one of my favorites, these are particularly nearby galaxies, is known as Centaurus A, which we'll show you here next. And these galaxies, as I said, have literally hundreds of billions of counterparts out in this map we are making. These are the near ones. They're big and bright because they're so close. This one, for example, is nearer than what we would say 4 million parsecs, or roughly 10 million light years. So that's one of the nearest objects in the sky. And the big dust lane across it, it's because it's just consumed one of its friends. So it's a cannibal eating its lunch in action. So have a chance, if you have a chance, go out and have a look at the web page, and you can explore, like astronomers are going to use this data set to go out and find the interesting things in the sky that we can then train our larger and more powerful telescopes on. This is sort of the treasure map for astronomers in the southern sky.